Hello students, today we are going to discuss on a topic that is the process of fertilization. So fertilization is the process by which the male and the female gamete meets, fuse and form a zygote. So the gametes, both the ovum and the sperm, they carry 23 chromosome, or that is N, indicated as N number of chromosome, half chromosome it is present, and by this fusion of male and the female gamete it produces a diploid zygote, or it's going to have twice N or 46 chromosome. And this gametic formation, the gamete formation is actually the process of meiosis, so that reduction division can occur, and due to the fusion, when both the male and the female gamete fuse, it can have the same chromosome number, that is twice N or 46 in case of human. So what is fertilization process? Fertilization process is fusion of male and the female gamete. The male gamete is called as spermatozoa and the female gamete is going to be the ovum, or that actually this is going to have a little problem here, that whenever both the male and the female gamete is in a point when fertilization will have to occur, at that time period that female gamete is not ready for fertilization, as we already have studied in the hormonal regulation as well as in the menstrual cycle that this female gamete completes only first meiosis. So first meiosis is only completed, so second meiosis if only completes, then only it is possible that fertilization process can occur. So fertilization process, whenever it is going to occur, at that time period the sperm attached to the layers of ovum, and only that time period the whole process, second meiosis, will be started, completes and form the two cells. One is second polar body, and after that we'll have the ovum. Then only the process of fertilization will occur. If suppose fertilization do not occur, then the female gamete do not ready, or it's not make itself ready for fertilization, as it is not completing the second meiosis. So we'll see in all these things later on. First of all, in this fertilization process, how this will occur? First of all, insemination is one thing. It's very much important. Insemination means the deposition of semen into the female reproductive tract. So if that semen that will contain the spermatozoa, or in one ejaculate, we should know that the spermatozoa count will be around 200 to 300 millions of spermatozoa, and along with that it will going to have liquid. That means on that liquid the spermatozoa will actually be present. So that liquid, that is known as semen, which is going to have fructose, calcium and some acidic component, as well as it is also going to have a number of hormones or some chemicals too. So those chemicals we'll see in this process of fertilization. It will be very much important. So what happens, that insemination, during insemination around 200 to 300 spermatozoa will be deposited. Why such a huge number of spermatozoa are deposited? See, one thing you should know, during insemination around 200 to 300 spermatozoa will get deposited in the female reproductive tract, but fertilization will occur by just the meeting of one male gamete with the ovum. Then why such huge numbers of spermatozoa are deposited? What is the reason why it's wasting maximum spermatozoa? Because to reach to the site of fertilization and to fertilize the ovum, that is actually a chance of once in a million. That means from this 200 to 300 spermatozoa to the site of fertilization, around only 300 to 500 sperm can reach. That means in the whole process, whenever the semen, along with the semen, the spermatozoa that will go to the site of fertilization, the spermatozoa actually go to the site of fertilization, there are only 300 to 500. So what happens, the spermatozoa which is metabolically highly active, and that spermatozoa which is having its maximum vigorous or highly motile cell, only that cell can reach the site of fertilization. So this is actually a process of natural selection where the best of the best spermatozoa will get the chance to reach the site of ovum and fertilize the ovum. So in that process, actually the fertilization process is a very unique process. It's so accurately occur so that no spermatozoa with some difficulty, less metabolic activity or defective, or this spermatozoa will not at all go to the site of fallopian tube and can reach the site of ovum. So that's why huge number of spermatozoa will be deposited. There is actually one condition. That condition is oligozoospermia. Oligospermia also we can call, oligozoospermia also we can call. So oligospermia is a condition when the semen in one ejaculate contain less than 20 millions of spermatozoa. So if that ejaculate, that semen contain less than 2 millions of spermatozoa, probably to the site of fertilization there are very less number or no spermatozoa can reach the site of fallopian tube, and that makes the male infertile or sterile. In that condition, maybe the sperm cannot fertilize the egg. Or there is another condition also we have, that is aspermia or azoospermia. So that condition is a condition when there is no ovum or there is no sperm. There is no sperm in the semen. That condition is known as azoospermia. In that condition, obviously the male will be infertile. But that condition, when oligospermia occurs, then the semen will contain around 200 millions of spermatozoa. So it is actually more than enough. But whenever it is reaching to the site of fallopian tube, from that 20 million, there may be very less or no spermatozoa can reach. So that's why this condition is known as oligospermia. In that case, the individual, the male, may be infertile. So in normal condition, in one insemination, that means in one ejaculation, around 200 to 300 millions. So here it should be 200 to 300 millions of spermatozoa will be deposited in the vagina, and from that only 300 to 500 sperm can reach the site of fallopian tube. That means 1 in a million can go to the site of fallopian tube. And why this is happening? What are those barriers which actually prevent the spermatozoa to reach the site of fallopian tube? So we will see those barriers. See what are those barriers. First of all, highly acidic pH. Acidic pH of the female tract. So what happened? The pH of the vagina and the tract actually have the pH of around 3.5. That is because of presence of some good bacteria or lactobacillus, which makes the environment acidic, so that the bacterial growth or any external microorganisms cannot grow in the fallopian tube. Because we should know, not fallopian tube, in the region of the external genital. What happens in the external genitals? This region is acidic, and one thing is there, that whenever it is going to reach a site of uterus, that uterus makes the most favorable environment so that a cell can proliferate, and this way after fertilization the embryo will start to grow. If any microbes somehow go to the site of the uterus or that middle body of the uterus, then there is no way that we can able to kill that. We can kill, but that environment is very much favorable for any microbe to grow. So that's why before the entry we have to kill all those pathogens or any another foreign particles or any another microorganism. So that's why naturally that environment is acidic, so that the foreign particles cannot grow. So that's why the female tract as well as the external genitals makes the pH of acidic around 3.5 pH. So in that environment also, if the semen is deposited, the sperm, most of the sperms get killed in this highly acidic medium, and that's why actually the semen is having the pH, basic pH around 7.5, around that pH, so that it can slightly decrease the acidity of the female tract and some of the spermatozoa can enter inside. So what happened? First of all, this is the barrier, that is the acidic pH of the female tract, which kill maximum spermatozoa even in the tract. Second one is the thickness of uterus. See, in the uterus lining, the thickness is thick due to the endometrium folds. So this is suppose the uterus. See, suppose this is the uterus. So that uterus will have highly convolutions of endometrium. So in that endometrium, most of the spermatozoa not even can go to the side, it will be trapped in that region. So that's why most of the spermatozoa will not even reach the site of fallopian tube. So here the fallopian tube is there, ampullary asystemic region, where the fertilization process will occur. So due to the thickness of the uterus, that is by the endometrium lining also, lots of spermatozoa will not able to go to the site of fallopian tube. Lots of another important barrier here, this one is due to the inability of sperm. See, whenever the spermatozoa around 200 to 300 millions of spermatozoa are deposited, from that all of the spermatozoa are not metabolically active, or it is not good spermatozoa, because around from that 200 to 300 millions of spermatozoa, at least 60% of them actually have good shape, size, etc. But rest of 40%, it's not going to have proper shape, or that maybe the tail structure is not good, or maybe the apical region, acrosome is not good enough so that it can fertilize a egg. So that's why in that region also the sperm is enabled. Most of the sperm, from the 200 to 300 millions of spermatozoa, only 60% of them is good in shape. And second of that, from that 60%, that 40% of them, only from that 60%, 40% of them is highly motile or highly metabolically active. They are only able to reach the site of fallopian tube. So we should know that lots of the sperms, they are non-motile. Lots of sperms, they will have horizontal movement, or their movement capacity is also very much less. Maybe it is possible the mitochondrial activity is less, their oxygen consumption is less. Due to all these factors, the metabolic activity and all, the spermatozoa is not able to reach the site of fallopian tube. So from that 200 to 300 millions of sperms, at least 60% of them should have good shape, size, and all this acrosome tail structure should be good. And from that, at least 40% of them should have their high metabolic activity, mitochondrial activity, oxygen consumption and all. So only because of that actually the sperm count is very much high in one ejaculate, so that from that actually some of them, very less percent, that can go to the site of 1% only can go to the site of fallopian tube. 1 in a million will go to the site of fallopian tube. Now one thing we should know, see here, this is the uterus, here this is the acidic environment, this is the vagina. Next one, here just above that, this is cervix, and after that whenever it is reaching outside above, that is the body of uterus. So what happened whenever the spermatozoa is reaching to the site here in the vaginal or cervical canal, in that region one very much important reaction will occur. What is that reaction? So just see, first of all, a very much important reaction will occur here, that is capacitation reaction. So what is capacitation? Very much important. See, as already I have told you what is decapacitation reaction in the male reproductive system. Just recall a little bit. In the male reproductive system, inside the seminiferous tubule, the spermatozoa are formed. After that, whenever it is going to the site of epididymis, it starts to get activate. That means the acrosome, the tip of the spermatozoa is called as acrosome. So that acrosome is active now. It starts to release the sperm lysine. It is going to release its enzyme, which is not actually needed in the male reproductive system. The sperm activity or that acrosomal activity is not needed. It will be needed only in the site of fertilization. Whenever it will reach the site of ovum, to lyse only the ovum membrane, the spermatozoa has to release this sperm lysines or those acrosomal enzymes. So in the male reproductive system, in the region of the epididymis, a reaction occurs, that is decapacitation reaction, where the acrosome will be covered by a layer of glycoprotein and cholesterol. So that reaction, when the activity of the spermatozoa is deactivated, that reaction is known as decapacitation reaction. Whenever that the semen with decapacitated spermatozoa are inseminated in this cervical and the vaginal canal, in that region the sperm are getting deactivated. That has to be capacitated once again. So how this capacitation reaction will occur? See, in the female tract, lots of phagocytes or some chemicals are there. So those chemicals actually can lyse the sperm glycoprotein or that cholesterol layer and once again make the spermatozoa active, so that now this acrosome can be capable of now release the sperm lysine. So that reaction is known as capacitation reaction. So just see here, suppose this is the spermatozoa. So that spermatozoa will have this apical or that tip. That tip is known as acrosome. In the male reproductive system, it is decapacitated by the formation of a glycoprotein and cholesterol layer above the acrosome. In the female reproductive tract, whenever the spermatozoa is reaching the site of cervical canal, in that region the capacitation reaction occurs. So in that capacitation reaction, the female tract release some chemicals and those chemicals actually lyse this glycoprotein layer. It sheds the glycoprotein layer and make the spermatozoa activate, or that acrosome is no more going to have any cholesterol layer. So it actually thinning the acrosome lining or that sperm membrane is getting thickened. It's getting thin, and this reaction is known as capacitation reaction. So first reaction occurs here where the sperm attain its functional maturity by this capacitation reaction. So capacitation reaction is the deactivation of the cholesterol or that glycoprotein layer above the spermatozoa by the release of some chemicals that are released by the that is released by the female tract itself, and this reaction where actually the spermatozoa attains the functional maturity. So whenever functional maturity is attained by the spermatozoa, at that time it also attain a aspiration so that it can go in an upward direction. So what happens in this time? Due to the thinning of this acrosome or that sperm membrane, it actually get permeable to the ions like calcium ion. So it is very much thin now. So calcium ion starts to enter inside the male gamete, and that makes the spermatozoa more active, so that now they can highly get activated and get the chance so that it can move in an upward direction, so that it can attain its swimming activity. So due to this capacitation reaction, it makes the sperm membrane more permeable to the calcium ion, and due to this inflow of the calcium ion inside the sperm, it gets the maximum swim activity. It gets actually highly active so that it can swim in an upward direction in the female tract. Now we'll see the process of fertilization in the steps. So let us see the events of fertilization. First of all, we have already seen the capacitation reaction. So in the capacitation reaction, what happens? The spermatozoa will attain the functional maturity, where the spermatozoal membrane, the acrosome, which was covered by the that acrosome was covered by the cholesterol or that glycoprotein and glycoprotein layer, that will be degenerated by the chemicals released by the female tract itself. It gives the spermatozoa more activity. Why this is happening? Because due to the lysing of this shedding or that lysing of this glycoprotein layer, it thin out the acrosome membrane, and due to what it actually gives permeability to the sperm membrane, and due to what number of calcium ion start to enter inside the spermatozoa, and because of that, due to the inflow of the calcium ion inside the spermatozoa, it gives actually movement to the spermatozoa. So that spermatozoa now will rise from the cervical canal to above. In that time period also, we should know how actually it will move against gravity towards the region of fertilization, that is ampullary ischemic region. So we should know here the ovum that was popped by the ovary, and after that it will be catched by the fallopian tube, and that ovum is now reached the site of fertilization, that is ampullary ischemic region. So in this ampullary ischemic region, the sperm has to move. So how this will happen? So first event that will occur, that is capacitation, where the sperm will attain the functional maturity by the lysing of the acrosome above layer. That glycoprotein layer will be shed, calcium ion will inflow, that gives motility to the sperm, and that sperm will reach towards the fundus region. Second important point, what happened? See, the sperm alone will not be deposited, it will be also the liquid, that semen will be also inseminated. So in that, it is going to have some molecules, some chemicals, some biomolecules will be present. As we can remember that the male accessory gland, seminal vesicle, prostate, bulbourethral gland, it released some chemical. Fructose was one of them. So fructose, why it was released? So that this fructose can be utilized by the sperm, and after that it can give the energy to the spermatozoa so that it can move in a upward direction. So the next thing, the mitochondria use this fructose, and after that it gives the movement, spermatozoa can rise. Next thing, a very much important thing is happening. See, the prostate gland release another chemical, that is prostaglandin. That prostaglandin is also present in the semen that is deposited in the female tract during insemination. So that prostaglandin as it is present in the semen, that will just start to bind with the receptors which is present in the uterine lining, and this makes a structure, hormone receptor complex. hormone receptor complex means the prostaglandin which is released by the male reproductive system. This prostaglandin have to bind with something so that it can start to show its function. So prostaglandin receptors are present on the uterine membrane. So during insemination, that semen that contain this prostaglandin which get bind with the receptors which is present on the uterine membrane. So this is the prostaglandin. So this prostaglandin is also going to bind with the receptors, gives a hormone receptor complex, and due to this hormone receptor complex, its activity is to develop a suction pull. Actually, that gives us contraction in the uterine membrane. So that uterine membrane will start to have a contraction, and during the 2 consecutive contraction there is a vacuum developed in the uterine cavity, and due to this vacuum actually the sperm get aspiration so that it can move in an upward direction towards the region of the fundus. So due to this hormone receptor complex, a suction pool is developed, and due to this suction pool, the spermatozoa now can reach this above in the uterine cavity. So the second important event that will occur right after capacitation, that is the mitochondrial activity. What is the mitochondrial activity? Mitochondrial activity is the semen which contain the fructose is gained by the mitochondria which is present in the middle space of the spermatozoa, and it utilize it for the energy production so that it can move in an upward direction, so that it can swim. Second one, the prostaglandin hormone receptor. So due to this prostaglandin hormone receptor complex, it develops a vacuum, and due to this vacuum actually the spermatozoa can move in an upward direction. So due to this mitochondrial activity and the hormone receptor complex is the hormone is this is the prostaglandin receptor which is present in the uterine lining. The hormone receptor complex has been formed, and after that it actually developed contraction, and during this uterine contraction a vacuum is developed, and due to this vacuum the sperm will move in an upward direction towards the fundus. Now it is moving vertically upward against gravity. Next thing, what will happen after that? Now see what happens. Due to the suction pull, that sperm will reach the site here in the fundus region. Now there is a similar type of reaction that is occurring in the female tract like the externally fertilized organism. See, what is external fertilization? External fertilization is a process of meeting of male and the female gamete outside the body. In case of fishes, the external fertilization occurs. So in external fertilization, what happens? Suppose there is a pond. In the pond, number of fishes are present. So the spermatozoa of one fish, how it can understand the ovum of the same species and can fertilize? So this is actually by releasing some chemicals. They are known as fertilizing, anti-fertilizing reaction, and that reaction is known as chemotaxis. So same type of chemotaxis is occurring in case of internally fertilizing organism, in case of human also. See here, there is an important reaction occurs, that is fertilizing, anti-fertilizing reaction. So in this fertilizing, anti-fertilizing reaction, what happens? First of all, fertilizing is a chemical released by the ovum, and anti-fertilizing is a chemical that is released by the sperm. So whenever the spermatozoa is reaching the site of fundus, it starts to release, the ovum starts to release the fertilizing chemical that attract the spermatozoa to reach the site of ampulla or ampullary ischemic junction from the fundus. So what happens? See, this is suppose the ovum. So this ovum releasing it's going to release a chemical that is fertilizing. So that fertilizing, see, that fertilizing have, this is the fertilizing suppose, so that fertilizing is going to have some spermophilic site. Very important thing, this is known as the spermophilic site. So spermophilic site is present in fertilizing. So this fertilizing is a chemical released by the ovum. So ovum release this chemical, and that chemical have the spermophilic site that attracts actually the spermatozoa to reach to the site of fertilization to the ampullary stomach region. Now this spermatozoa will bind to the spermophilic receptor of the ovum. So this, suppose here this is the fertilizing, and that fertilizing had this spermophilic site with which the spermatozoa will get bind. So what happened, this reaction will occur, and this fertilizing anti-fertilizing reaction, this is also called as chemotaxis. So chemotaxis is prevalent in case of externally fertilized organism, and similar type of chemicals are released by human also, human ovum and human sperm. And here what happened, this spermatozoa will reach the site of fertilization by this chemotaxis. So why this chemotaxis reaction occurs? See, whenever the spermatozoa was deposited, it was around 200 to 300 millions of spermatozoa. Due to the acidic medium, lots of spermatozoa dies. Due to the inability of capacitation reaction, lots of spermatozoa dies. Due to the abrupt environment, that is the uterine thickness of the spermatozoa, uterine thickness of the female tract, also a lot of spermatozoa dies. Due to the inability of the movement, swimming movement, a lot of spermatozoa dies. And this way, by the natural selection, this is actually a phenomenon by which naturally the most suitable organism can survive in nature. So that evolution teaches us. We'll see that later in another chapter. So by this natural selection process, the spermatozoa, which is the most active, that will go to the site of fertilization. So from the 200 to 300 millions of spermatozoa, around 300 to 500 spermatozoa will reach. Then also it is very much high. So what happened here, this chemotaxis reaction occurs due to the thinning out of the spermatozoa count. That means that because of this fertilizing, you can see the fertilizing chemical of the ovum, they have very less spermophilic site. So because of that, number of spermatozoa suppose reaching the site, but a number of spermatozoa is not able to bind with this spermophilic site. So that's why this chemotaxis will decrease down, it will less down the sperm number so that it can bind to the spermophilic site and can get the chance to fertilize the ova. So this chemotaxis is due to thin out the sperm number. And second one, it is also very much important, it is species specific. See what happens, somehow if it is happening that suppose the spermatozoa of a different species enters inside the female tract, it will not get a chance so that it can fertilize the ovum of the human ovum. So what happens, this spermophilic site, it is very much specific so that only the human sperm can get attached. So here what happens, so that another species spermatozoa will not get attached, this spermophilic site will make it sure that it is only the human sperm, not of another species. So this fertilizing anti-fertilizing reaction or chemotaxis is due to of two main reasons. One is to thin out the sperm number, and second one is actually to block the another species spermatozoa to fertilize the ovum. So it is also species specific. So these reactions will occur before they can reach the site of fertilization. After that, we'll see what will happen in the region of ampullary ischemic region. Now see, after all these phases, the spermatozoa will pass, and after that it will reach the site of fertilization. So we have zoomed the structure, the ovum, which is arrested in the metaphase 2 of the second meiosis. So this is the secondary oocyte itself. So this secondary oocyte is going to have the membranes. First, outermost membrane, this is known as corona radiata cells, as well as the cells of cumulus ophorus. That means these are the cells of the granulosa cells. So after that, see those corona radiata cells and cumulus ophorus or cells of numbers of cells are present. You can see outside are numbers of granulosa cells, that are the cumulus ophorus, as well as the corona radiata cells are present. These cells are glued together by an acid, that is hyaluronic acid. You can see that red colored substance is hyaluronic acid that actually glue the corona radiata cells outside the cell, outside the ovum. Now, after, just beneath the corona radiata, there is another non-cellular layer made up of glycoprotein layer, that is zona pellucida, and the last membrane, that is known as the egg membrane or the vitelline membrane. So this vitelline membrane, see, important thing is here that egg has how many membranes, or those membranes we will call it as primary membrane, secondary membrane or tertiary membrane. What are those actually? First of all, the egg itself release the egg membrane or plasma membrane, that is known as vitelline membrane. So that membrane which is released by the egg itself, that is known as the vitelline membrane. This is the primary layer. The second one, this is the non-cellular layer called zona pellucida. So that zona pellucida are actually released by the follicular cells, or that cells of corona radiata and cumulus ophorus. So those cells, follicular cells, they release the zona pellucida. So this zona pellucida is the secondary egg membrane or the secondary layer, and the outermost corona radiata cells or the cumulus ophorus or cells of the cells, these are actually the same follicular cells. So this zona pellucida and the corona radiata, these are both these two layers, they are the secondary layers. So this zona pellucida which is released by the follicular cells, and this corona radiata which is itself the follicular cells. So both these two are secondary layer or secondary membrane. The egg, some of the species have the tertiary egg membrane also, which is the calcareous shell present in case of, suppose, chicken we have seen. This is made up of some calcareous layer which is very much protective and hard, that is present in some case of oviparous animal, like in case of birds we can see, which is not in case of human present. So it is going to have only the primary membrane, that is the vitelline membrane, and secondary membrane, that are the zona pellucida and the corona radiata cell layer. Now towards the side here, the numbers of sperms, that are around 300 to 500 sperm, can reach. Now from that it will actually very less number of sperm get the chance, so that it can fertilize those membranes. So first of all we should know that this sperm, here I am drawing it, the sperm has the tip that is known as the acrosome, and this acrosome will release. Now the function of acrosome will be started here only. Whenever the spermatozoa will actually try to invade all this membrane and can try to go to reach the site of egg membrane or this vitelline membrane, then only it will able to deposit the nucleus. So before that they have to cross all those barriers, barrier of corona radiata, zona pellucida, and after that it has to hit the vitelline membrane. So this acrosome will release 3 different type of chemicals. They are known as the sperm lysins. 3 different type of enzymes will be released. So the first enzyme that is released by the acrosome, that is known as hyaluronidase. So what is the function of hyaluronidase enzyme? As we can see here, it is the hyaluronic acid which glue the cells of the corona radiata. So this hyaluronic acid will actually degenerate those hyaluronic acid, and because of that the cells of corona radiata get actually separated from each other. Next one, second very much important enzyme, that is known as the corona penetrating enzyme. So it's also called a CPE, corona penetrating enzyme, that is actually released by the acrosome later on after hyaluronidase. First of all, hyaluronidase will dissolve the hyaluronic acid. Because of that, the cells of corona radiata will start to detach from each other, and after that, due to CPE, corona penetrating enzyme, those cells will actually get dispersed from each other, and they start to get dispersed from the site where the egg is released, where the sperm is releasing the CPE. So from that site, the cells of corona radiata will start to get dispersed. Suppose here those cells will be present, but from those sites, from this region, the cells of corona radiata will start to separate from each other, so that the spermatozoa will reach to the site here, and in this region the spermatozoa will attach to the zona pellucida. So here in the zona pellucida, there is a chemical present on the zona pellucida layer. There is a chemical present, and that chemical is known as ZP3. So whenever this sperm head, the acrosome, hit the ZP3 of zona pellucida, it induced the acrosome to release the third sperm lysine, and the third sperm lysine is known as the acrosine. So this acrosine will be released by the spermatozoa when the ZP3, that is actually one attachment site of the zona pellucida layer of the egg itself. So whenever the spermatozoa will attach to the ZP3 of the zona pellucida layer, it is induced and start to release acrosine. So whenever it is releasing this acrosine, it will lyse this zona pellucida layer only from that site, and after that this egg will, for the first time, it can reach the site here in this region and can attach the site of that egg membrane or that vitelline membrane. So after that, this spermatozoa will here just about to attach. Whenever it is just about to attach this layer, vitelline membrane, the vitelline membrane will develop a cone-like structure, and that cone, it is known as the fertilization cone. So this spermatozoa head, as soon as it is reaching, it breaks the zona pellucida, and that very much time this layer, vitelline membrane, will develop a cone-like structure that is known as the fertilization cone. So fertilization cone will be formed, and it is the site of penetration of the sperm. So whenever the sperm is about to hit this vitelline membrane, at that time period, whenever this spermatozoa attach this fertilization cone, at that time the ovum, which is now in the secondary oocyte state, it is now induced to complete the state meiosis 2. So as we can see here, this spermatozoa attachment induced this ovum to complete the meiosis 2. So in the meiosis 2, the ovum is arrested in the metaphase 2. So in this meiosis 2, the metaphase 2 is the phase where the secondary oocyte is restricted. So at that time, the spermatozoa will break the metaphase promoting factor, and it induce or stimulate the anaphase promoting factor. And because of this anaphase promoting factor, what happened, the secondary oocyte completes. After anaphase, telophase occurs, and here also unequal division occurs, and due to the unequal division it completes the second meiosis and it produces two cells. One is the definitive ovum, which is now ready for fertilization, and another cell will be formed. This is known as the second polar body. So second polar body will be formed after that. Here we can see, suppose this is the cell, the ovum nucleus. In the nucleus it is going to have 23 chromosome, n number of chromosome, but it is in the doublet state. So in that it is restricting in the metaphase 2 due to the heating of the sperm membrane with the fertilization cone of the ovum. It actually dissolved the metaphase, restricting in the restricted state. So metaphase promoting factor will be dissolved and stimulate the anaphase promoting factor. The ovum will complete anaphase 2, and after that it completes telophase 2. After that unequal cytokinesis will occur and it produces two cells. One cell, this is known as the ovum, which is now present here, and another is the second polar body, and that second polar body will start to remove from where the spermatozoa hit the sperm membrane, the spermatozoa hit the ovum. In that region only the membranes, the corona radiata, zona pellucida layers are not present. So from that region the second polar body, this is the second polar body. So second polar body will be removed outside. It will be thrown outside by the oocyte or the ovum itself, and that region from where the second polar body is removed and the spermatozoa is attached to the vitelline membrane, that site, this region, this specific region, this is known as the animal pole. This is known as the animal pole, and exactly the opposite pole, this pole is known as the vegetal pole. So due to that a polarity is developed, animal pole, from where the spermatozoa attached to the spermatozoa attached to the egg membrane and second polar body is removed, and that region is known as animal pole. Exactly opposite to the animal pole there is another pole developed, that is known as vegetal pole, and this animal pole and vegetal pole is the axis where this axis is developed. From that axis in future the zygote will undergo a cleavage furrow. So this way a cleavage furrow will be formed and that zygote will form two cells. So this is the phase when animal pole, vegetal pole develops. Now see, this egg membrane develops this fertilization cone, and because of that the sperm head is also going to attach to the egg membrane. Now just see the next event, what will happen, a very much important reaction happens. This is known as cortical granule reaction. So what is cortical granule reaction? See, first of all, the egg cytoplasm, as you can remember, the egg cytoplasm that is divided into two parts. One is ooplasm, which is present in the middle. So this is the ooplasm, and the cortex, which is on the periphery, towards the periphery, this is known as the cortical cytoplasm. So this cortical cytoplasm is very much thicker, as it is going to have numbers of granules here, and this ooplasm, which is a little bit less dense, which is going to have all other microorganelles. So this cytoplasm plays important role. So cytoplasm of the egg is divided into two parts. One is the ooplasm, which is middle, less dense part, which contain all the microorganelles as well as the nucleus. or germinal vesicle we can call, and the cortex, which is going to be dense due to the presence of some cortical granule. As soon as the sperm head attaches, at that time the cortical granule start to get active, and at that very much important time, in that time period, this actually opens the channel for sodium. So inflow of sodium occurs. So sodium ion start to inflow inside the ovum, that develops the polarization. The egg membrane will actually start to get depolarized. So inflow of sodium ion occurs, as we can remember in the first year we got the whole process of conduction of nerve impulse. So AMP is developed here in the egg membrane due to the inflow of the sodium ion. So due to the sodium ion inflow, the egg actually develops polarity. So polarity is developed in the egg membrane. Polarity in the egg membrane is developed here. And at that very much time, what happens? This egg membrane and the sperm membrane or that acrosome, that actually get dissolved, and whenever it dissolves, it develops only one membrane. So here you can see the sperm membrane and the egg membrane start to get dissolved. In that very much time, what happens in the region, cortical granules are already present here. So it is present in this region. At that time, the calcium ion will also start to enter. So calcium ion will start to enter, and that calcium ion induce extrusion of those cortical granule towards the vitelline membrane. So this cortical granule will push towards this perivitelline space and will actually start to present exactly here in the region egg, towards the egg membrane, just leaving the site of attachment of the sperm, and in the whole egg membrane this cortical granule attaches this egg membrane or the vitelline membrane. So this is the reaction. This is called as the cortical granule reaction. What is happening? The egg attached with the sperm head due to a fertilization cone is developed. Sodium ion inflow occurs, the egg membrane get depolarized. In that very much time, due to the depolarization, calcium ion open, the calcium ion channels are open, the calcium ion inflow will occur, that induce the extrusion. That means the calcium ion will extrude the cortical granules towards the egg membrane or that vitelline membrane from the dense egg cortex. At that very much time, what happened? It develops a block, so that whenever the sperm is about to deposit the nucleus, the fertilization process is going to occur, fusion of male and female gamete is about to occur in that very same time, so that no another spermatozoa can deposit their chromosome inside the female gamete. So that's why this reaction will occur. So this reaction is actually to prevent, polyspermy. That means a number of sperms is not allowed to deposit their nucleus. Only one sperm will fertilize the egg. So that's why we'll have this important reaction that is called as the cortical granule reaction. So cortical granule reaction completes. So whenever cortical granule reaction completes, after that what happens? After that, you can see here from this egg membrane, you can see the egg membrane will once again form, leaving the sperm membrane outside. And in that period of time, from the sperm, how many things will enter? Only that nucleus of the sperm, the egg nucleus is already present here. So that nucleus of the sperm enters. Along with that, this mitochondria will also enter from the spermatozoa. Mitochondria will enter. You can see mitochondria will also enter. And along with that, another very much important thing, that is centriole. So that centriole will also enter. So from that region, the animal pole region, the animal pole region is the region from where mitochondria, nucleus and the centriole will enter. But this centriole will go at exactly right angle. That means it will migrate first of all from this animal pole, then after that it will go at right angle, and after that it will go to the cortex, and whenever it is reaching the cortex, it will develop some mitotic spindle so that it can be ready for the cleavage. So here in this region, this centriole, mitochondria and the nucleus of the sperm enters. So as soon as it is entering, the sperm membrane, the plasma membrane of the sperm will left outside, and whenever this left outside, next reaction will occur, that is known as the syngamy or fusion of the male and the female nucleus. So male and the female gamete will fuse, and after that it will develop the twice-end nucleus. So here this structure will now going to have the twice-end chromosome number, and whenever this twice-end number is being formed, this is called as the zygote. So this region is the animal pole from where the spermatozoa deposits the nucleus, mitochondria and the centriole, and the opposite region, this is known as the vegetal pole. The opposite of the animal pole is called as the vegetal pole. As soon as this zygote is been formed, in that very much time it will also prepare itself for the next step. That means as soon as this zygote is been formed, after 24 hours it will actually prepare itself for the next cleavage. That means from one cell stage, see, in case of us, we are going to have numbers of cells. We are eukaryotes, we have numbers of cells, we have millions, trillions of cells in our body. So first of all, we are starting our life from the zygote. So zygote, as soon as it is formed, it is going to have only one cell. So from one cell it is going to undergo the next step, that is mitotic, simple duplication of the cell. From one cell it will form two cells. From here, exactly at right angle, it will develop the cleavage furrow, and after that from animal pole, vegetal pole lining, a cleavage furrow will be formed, and after that this nucleus, see, you can have twice-end nucleus, then after that the chromosome that will once again, see, these are the chromatids. So 50% will be from the maternal side and 50% will be from the paternal side. So this actually present on the equatorial plane, and after that this mitotic spindle will actually start to bring those nucleus towards the pole. So whenever these are coming towards the pole, once again duplication occurs, and after that here from this animal pole, vegetal pole axis, one cell divides to two cells, and this will be the first cleavage, and after first cleavage two cell stage has been formed, and that structure, that is, see, from one cell each of them will have two cells. Each of the cells are known as the blastomeres. So two blastomeres are formed after first cleavage. After first cleavage, now right angle to the first cleavage, after 24 hours it will form 4 blastomeres. So this is after second cleavage. This is after second cleavage. From 2 cell it will form 4 cell. So here you just need to observe one very much important thing, that whenever that zygote undergo first cleavage, from first cleavage it will undergo second cleavage, just the nucleus is dividing. It is not having any duplication of the cytoplasm. So that's why as we are from first cleavage to the second cleavage, the cell size will start to decrease. Why? Because cytoplasm content is going to decrease in each cleavage. In every 24 hours, one cleavage will occur, and after every cleavage, what we are going to have, the cells that will be more in number, but the cytoplasm number will start to decline. So this way, after first cleavage, it will have second cleavage, four cell stage will be formed, and gradually we'll see the next stage, that is the morula formation, blastula formation. Then after that we'll see implantation process. So this is the whole step of the fertilization process. So this way fertilization is completed. So in next video we'll see the implantation, blastulation, morula formation, blastula formation, and then after that we'll see implantation. So that's all about fertilization. Thank you.